multiplying. Remember, the rules are a little bit tricky. Yes, we have. All right. All right, so here are the rules for multiplication. They're a little bit trickier. We're going to multiply A times F. A is back here, so I got to get A back here. So A is the matrix 1, 2, 3, negative 4. And I'm going to multiply that by F, which is the matrix negative 1, 5, 3, 0. All right? Now, I need everybody paying attention to this. It isn't hard, but it is so much easier to show than it is to try to follow an example or read the directions, okay? We're going to multiply these two together. Now, here's the rule for multiplication. Figure out the dimensions of this matrix. Well, that's easy. It has 2 rows and 2 columns, so this is a 2 by 2. Figure out the dimensions of this one. It's a 2 by 2. Everybody okay? If they're going to be multipliable, these two numbers must match. Notice, I didn't say they have to be the same size. If you're adding and subtracting, they have to be the same size. If you are multiplying, the only rule is these two have to match. So you could have an 8 by 6 and a 6 by 2 and multiply. The rule for multiplication is these two match. These two tell you the size of your answer. So if I'm multiplying a 2 by 2 and a 2 by 2, these match, and my answer will be another 2 by 2. If I were multiplying these, an 8 by 6 and a 6 by 2, these match, and my answer would be 8 by 2. Okay? Now, you figured out your answer is a 2 by 2. It has 2 rows and 2 columns. To find this spot right here, which I'm just going to call 1, 1, that's row 1, column 1. You are going to multiply row 1 and column 1. In other words, you are going to take the first number times the first number, the second number times the second number, and add them up. So I'm going to get 1 times negative 1, 2 times 3, and I'm going to add them up. So that gives me what? 5. So this number is a 5. All right, now let's see if you can figure out how to do this one. What's this? That's row 1, column 2. So now I'm going to take row 1 times column 2. So we take first times first, and second times second, and we add them up. So what do we get? 5. So this number is another 5. That's coincidence. Now what about this one? Where is he? He is in row 2, column 1. So now I'm going to multiply row 2 times column 1. So 3 times negative 1, first times first, and negative 4 times 3, second times second, that adds up to negative 15. Now what's this spot? Second row, second column? So here we go, second row, second column. So 3 times 5, first times first, second times second. What do I come up with? 15. And there you go. You have multiplied your first matrices together, unless you did that last year too. It's a little more complicated than the adding and subtracting thing. Is it an emergency? Yeah. All right, hurry up. All right, now we're going to multiply F times A. Now we just did A times F. I wonder if they'll be the same. Let's see. Now, first of all, can we multiply? Yes, because this is 2 by 2, and this is 2 by 2, and those match. Remember, that's the rule. Those have to match. Now, the answer is going to be another 2 by 2. To fill in each blank, you multiply the row and the column for that blank. So in other words, this is the row 1, column 1 spot. Yep. So you're going to multiply row 1 times column 1. So we take row 1, take these two numbers times these two numbers. So negative 1 times 1, 5 times 3, and add them up. What's that first number? 14. Now, first row, second column. If you're having a hard time keeping all these numbers straight, go ahead and write down these two numbers, and then write down these two numbers. That's what you're multiplying every time. So that makes negative 22. Are these turning out the same answers? No, so in other words, it matters what order you do it. AF and FA are not the same. All right, row 2, column 1, here we go. What do you get there? Can you get that one by yourself? Row 2, column 1, what do we end up with? 3. If you said 3, you are right. Those of you not getting 3, you're taking 3 and 0 times 1 and 3. So you're getting 3. And what about that last spot? That's 6. And again, it's 3 and 0 times 2 and negative 4. That's how we got 6. Little tricky to multiply. All right, let's try the next one. How about D times E? What are the dimensions of D? How big is D? D is a 2 by 2. What is E?
3 by 3.
Uh-oh. Can I even multiply a 2 by 2 times a 3 by 3? No, because these don't match. So the answer to this problem would be empty set. All right, Next, D times G. Can I multiply D times G?
Yeah.
Well, what are the dimensions of D? 2 by 2. What are the dimensions of G? 2 by 3. They match. So my answer will be a 2 by 3. So matrix D and matrix G. All right, I'm going to multiply these together. Yes, and we have figured out that this will be a 2 by 3 matrix. You already figured that out. You're going to have 2 rows and 3 columns. All right, so here we go. Row 1, column 1, right there. So row 1, column 1. So we're taking 1 and 1 times 1 and negative 3. 1 times 1, 1 times negative 3. So that's a negative 2. This number is going to be a negative 2. All right, would you go ahead and fill in the rest of them? And then I'll fill them in and we'll see how many you got right. Go ahead, Paul, put a pencil in your hand. Let's go. Remember, to get this number right here, you'll be doing the first row and the second column. Yep. Okay. How about these numbers? Anybody want to ask about one of them? You got all these? All that's good? Anybody have a question about where one of these numbers came from? You got a different number, maybe. All right, there's one more example. Oh no, I guess there's 2 more. But here, let's do GE. We're going to multiply G times E. What are the dimensions of G?
2 by 3.
Here's G, and his dimensions are 2 by 3. And here's E. And he is 3 by 3. can they be multiplied? Yes, because these match. And how big will the answer be? 2 rows and 3 columns. The answer will be a 2 by 3. Now this one's going to be a little bit tougher because when you multiply row 1 by column 1, you have 3 numbers to keep track of. So here are the numbers in row 1. Here are the numbers in column 1. So you're going to do that multiplication and add them up. And you can do that in your head, but it might be easier to write it down. So I wrote down all the numbers in row 1. And then right next to that, I wrote down all the numbers in column 1. And now I'm going to multiply. So what do I have? 1 plus 2 minus 3, which is 0. That's a 0. Now you can move around to however you want. If I do this next, this is row 1, column 2. So I'm going to take the numbers in row 1. Watch how I'm doing that. I just wrote down the numbers in row 1. Now I'm going to write down the numbers in column 2. The numbers in column 2. And now I'm going to add them up. So what do I have? 6. Now this spot, I'm going to multiply row 1 and column 3. So here's row 1 again, 1, 2, 3. And here's column 3, 0, 3, 4. What do I get for that? What'd you get? 18? Alright, now I need this spot. Now which spot is this? This is in row 2, column 1. So row 2, those numbers are negative 3, 1, and 0. And then column 1 is 1, 1, negative 1. You get negative 2. Very good. Alright, see if you can fill in the last 2 on your own. See if you can fill in the last 2, which would be row 2, column 2, and then row 2, column 3. What do you think for those last 2 spots? Avery, what'd you get? 5 and 3. Avery's got it. She's got it. That's correct. 5 and 3. Anybody have a question about the 5 and 3? Pardon me? Yes. Okay. All right, one more multiplication problem, and then we'll do a little review. F times G. Alright, so F is this, and G is this. Alright, this is on page 45. It says multiply F times G. So here's F and here's G. Here we go. What do you think? Can they be multiplied? Well, this is a 2 by 2, and this is a 2 by 3, so the answer is yes. And the answer will be a 2 by 3. Two rows, 3 columns. All right, fill it in. See how you do all by yourselves on this one. Whole thing. Row 1 times column 1. Here we go. Bless you. Well, we have a quiz over elimination and substitution on Thursday. And then probably the following Monday, we'll have a quiz over basic matrix stuff. You got any of these answers yet? Any of the numbers at all?
Yeah.
Okay, across the top? Okay, what are they? And what? -3. All right, anybody, Ken's got the top row done. Anybody want to talk about any of those?
-10, we got -6.
Yeah, I'm not sure about that -10 thing. You're taking the first row times the first column. So it'll be -1 and 5 times 1 and -3. I think that's going to be -16. And I think the rest of them are right though across the top. Now, row 2, column 1, 2, and 3. Who's got those numbers for me? Anybody have those figured out in the bottom yet?
3, 6,
3, 6, 9, he says. Anybody want to discuss those? Talk about them, question them?
Well, you have a 0, so you know that. But you know if you have 0, sometimes those.
All right, anybody have a question about that? Okay, let me give you then one more thing. And let's look at the paper right on top. We're looking at the paper right on top. All right, let's take a look at this practice quiz here and get as much of it done as we can. Remember remember that on Thursday we will have a quiz like problem number 1, just a system of equations, and it says solve using substitution or elimination. Alrighty, so here we go. When you look at this problem, you could actually do it both ways, and I'll do it both ways. But when you look at it, what occurs to you? Do you see a substitution or do you see an elimination? You see an elimination. Now, we're going to do it both ways. Elimination first. If you see elimination, then you know you either have to make these two cancel or these two cancel. It's going to be easiest to make these cancel, because all you're going to need to do is multiply the top row by 2. Because we're going to have 4x plus 2y equals 10. I'm planning ahead. When I add that to this second equation, the y's are going to cancel. That's why we multiplied by 2, so that the y's would cancel. So 7x equals 14 and x equals 2. Now, the answer is not x equals 2. The answer is 2 comma something. And the something would be found by plugging in 2 for the x. So y is 1. Is that okay with everybody? Now, this is what you do if when you look at the problem you see elimination. Philip, you said you see substitution. So what are you going to do? You're going to subtract 2x. So y equals 5 minus 2x. And then you're going to take this and plug him in right here. So 3x minus 2 times 5 minus 2x equals 4. Excuse me. So we have 3x minus 10 plus 4x. Watch your arithmetic. So 7x minus 10 equals 4. Look what's going to happen. 7x equals 14 and x equals 2. Did we expect that to happen? Yeah, there's only one answer, and it doesn't matter how you do it. You're going to get that answer unless you mess up. And then you take that 2 and plug it back in wherever you want. It's easy right here, and you get 1. Now, obviously, you're not going to have to do the same problem twice, but you are going to have to know how to substitute and how to eliminate. So we just practiced again. And there are homework problems that do that practice that you can work on. Quiz on Thursday. We have to be able to substitute and eliminate. Got it? All right, let's get a few more down here. A plus B. Now I'm doing some matrix arithmetic. A plus B. What will that be? A plus B. Oh, this is supposed to be easy.
A plus B.
Uh-huh.
1, 0,
0, 2, 8, and 10. There it is. How do we add matrices? Listen, it's just common sense. Nobody has to tell you this. You add the numbers that are in the same spots. Are there any times that you can't add? Yes, if they're not the same size. The matrices have to match. B, 2C. 2C will be -2, 2, 4.
6, 10, 8.
Easy. Easy, easy, easy. A plus C. No solution. C is cannot do. Why can't you add A and C? Because they are different sizes. Different sizes mean you cannot add them. All right, backside. D, A sub 2, 1. What is A sub 2, 1? What? 3. A sub 2, 1 is 3. Now, boys and girls, I know this is a god-awful period. This long period after lunch, I know how hard it is, but we have got to get our work done. If you think you might forget what A sub 2, 1 means, make a note. That is the entry in matrix A that is in the second row, first column. The answer is 3. It is 3. Second row, first column of matrix A, 3. What are the dimensions of C? 2 by 3. And we write that 2 by 3. Writing it any other way is going to be wrong. It's written 2 by 3. That's the dimensions. A times B. All right? A times B. This is your exit ticket. Figure out what A times B is. Bring it now. You cannot bring it up and show me until I have had a chance to figure it out. All right? So I need to figure it out. A times B, bring it up and show me. Ellie, would you turn that off, please?